Well, this is so far regarding the with the classification and the main characteristics of the inorganic and organic substrates. However, either inorganic or organic substrate must fulfill some basic requirement for use as media to grow plants, and on this framework we can talk about a number of requirements, like they should have adequate mechanical properties to guarantee the plant stability. They should have low bulk density to facilitate the installation of growing systems. They must have high porosity at the level from 50 to 85%. They must guarantee a consistent distribution of the air, of the oxygen and water in order to sustain the root activity. It is required that pH of a substrate to be between 5 and 6.5, or at least it must be easily adjustable to this level, either by adding acids or calcium carbonate, depending on the situation, and it must have low soluble salt content. Also, substrate must be chemically inert, and it means that it should not interfere with nutrient solution by releasing inorganic ions and toxic exudates, or by immobilizing the nutrients like phosphorus and nitrogen, and as it happens in some organic substrate. We explained this before. In addition, the substrate must have the ability to maintain the original characteristics during the cultivation, and which in some cases might be quite long. It must be free of pathogens and pests, and this do not necessarily mean that it should be sterile, but it should be free of pathogens and pests. And finally, it must be available in standardized and uniform batch in order to permit the use of consistent fertilization and irrigation programs for each successive crop. So there is a long list of basic requirements a substrate needs to fulfill for commercial production. And this is a summary of some basic characteristics of specifically of the bulk density and porosity of main inorganic substrate, and you can see that there is here a variation of both characteristics, but especially of the bulk density, which is indeed a bit high in case of the expanded clay and pumice, and much less in case of peat, vermiculite, perlite, and rockwool. There's some variation also regarding the total porosity, and you can see that again the pumice is with a lower total porosity. In addition, you can see in this table here also some information regarding the volumetric water content at different matrix potentials of some organic and inorganic materials, and you can see that the highest in water holding capacity are the coconuts and the perlites, and as you find that mixtures of peat and perlite and peat and pumice have a lower volumetric water content. This is something we need to know in order to define the frequency of irrigation and the dosage of water during the irrigation. Finally, in this lesson, we need to be aware for the fact that during the use, the substrate can be subject of several modifications which can alter their physical, chemical and biological properties, and usually deteriorate their physical, chemical and biological properties, and finally make them impossible to further use for growing plants. Well, the first, there are alterations of porosity and water holding capacity, which can be due to the decomposition of organic matter. It can be due to the activity of the root system of plants growing there, and this results in aggregation and segregation of fine particles, swelling and shrinkage to the wetting or drying cycles and things like that. I need to say that the organic substrates are more sensitive, let's say, to this kind of modifications or alterations. Next, or secondly, in a substrate can happen changes in the pH and electrical conductivity, and normally higher salinity levels and higher pH levels are detected at the end of the cultivation, and this is a result of fertigation with alkaline or saline water or concentrated nutrient solutions, when we are using higher amounts of nutrients than the plant can absorb. And then third, substrate might be subject of proliferation of pathogens and parasites, in particular nematodes, and then we can negatively affect the subsequent plants. And finally, in a substrate we can find accumulation of toxic compounds which are released from the roots or from the decomposition of organic matter, or simply their ions which are not absorbed, uptaken, toxic ions which are not uptaken from the plants during the entire plant growth cycle. So this is what we should expect from the use or during the use of a substrate, and therefore is a need that to analyze the growing media regularly during the growing cycle before it's used for the first time and before it's reused in a successive crop. And this is important to accordingly adjust the fertigation cycles and to adjust the composition of the nutrient solution in order to expand the use of the substrates. And here you can find in this table here some guided values regarding the pH, the electrical conductivity, ion concentration of greenhouse media, and then to use them as reference values for the further use of substrate or not. So this is all for this lesson, and again you can find here a short list of some publications which you can use to further extend the know-hows or knowledge regarding the topic we discussed today, the substrates, the properties, the physical, chemical and biological properties properties, their use and their alterations or modification during the growing plants. Again, thank you very much for attending me in this lesson, and I invite you to follow me again in the next lessons. Thank you.